We're going to be taking a look at section 7.8 in the video that I'm just getting ready to set up here. In 7.8, we're solving problems using quadratic models. What we're going to do is gather together some strategies for solving real-life problems using the quadratic models. So we have a chance in this particular section to put together everything we've learned about the quadratics, all the tools that you have for understanding what a graph looks like, whether it's in the standard form or the vertex form or the factored form. So we've learned all kinds of tools, and now we're going to use them in some real-life problems. We've broken this particular section into two classes, and so firstly, we're going to be just looking at some of the things about where we start. So first, some hints, so that you're not frustrated with the work we do. Always name the variables. And if you're having trouble figuring out what the variables should be, go to the question, look at the question, and usually that question will guide you a little bit and help you understand what X should be in this particular situation. There's always a relationship of some kind that creates a quadratic, so you'll know that you're on track if what you've done looks like a quadratic when you're finished. Always, when you've got your quadratic ready and you're getting ready to solve it, you need to decide what part of the quadratic is being requested. Are they asking in a roundabout way for the vertex or the x-intercepts or the y-intercept? So you need to determine that, and that will guide you in what you're going to use. Remember, make use of the calculator if you're allowed to use one. And practice will help you. This is one of those times where you have to do the work. You can't just sit back and watch what's happening. Using the solutions will help you. I do expect you to use them and let them guide you a little bit. But remember that copying the solutions serves no positive purpose at all. You're just wasting your time. What you use the solutions for is to give it a try yourself. If it's not going well, take a peek at what I've done, see if it guides you in the next step that you need. So there are different styles of questions that we're going to look at, and I've tried to group them together to help you manage them a little bit better. The first one is where the model is given to us. It usually describes the motion of an object or the way in which something is behaving. But whatever it is, the model is given. The first one we looked at involved a bridge. And it was a bridge. If you look down, you can see for sure that there is this parabolic arch underneath the bridge supporting it. So the engineers who designed the Coal River Bridge on the Alaska Highway in BC used a supporting arch with twin metal arcs. The function that describes the arch is the following function, where h is the height in meters of the arch above the ice, and x is the distance in meters from one end of the bridge. So the question was, what is the distance between the bases? So let's take a look at what we've done. First of all, you'll notice that I always write the equation out and that I indicate what these variables stand for. That helps you when it comes to interpreting your work at the end of it. Looking at this, I can tell that I should have a quadratic that opens down. It has a y-intercept of 0. And I can tell because this is a very small number that it's going to be a very flat quadratic. So they've asked me to find the distance between the arcs, which is basically the distance between the zeros, or the x-intercepts. I know already that one of the intercepts is at 0, so I need to find the other one. So in class, we talked about quite a bit, how do we use our calculators to do this? Well, you're going to put this, of course, into the y equals function, but you've got to be smart about it. You've got to realize that your graphing calculator is set with a maximum x of 10. And so the distance between the arcs is clearly more than 10. So you're going to have to play around with that a little bit, and you should practice doing that. Playing around with numbers, changing the maximum value for x so that you can see more along the x-axis. And eventually, if you use about 120, 150, you start to see a function that looks a little bit like this one. I'm still using from -10 to 120. And that allows me to be able to find my x-intercepts pretty easily with my calculator. It comes out to be that it is 98.6. So the distance between the base of this arc is 98.6. You'll notice I did adjust for this particular frame. I adjusted so I could see the top of my graph. If you left it at 10, you're just not going to see it. But when you come to the next part, where we ask you to find the maximum height, you're going to want to adjust it so that you can see it once again and find the vertex. The vertex takes place at 49.3 and it is a height of 12.3. So we interpret that as the maximum height is 12.3 meters. It's good to note as well that in both these scenarios, when you were trying to calculate them, if we were trying to find the x-intercepts and we didn't have a graphing calculator, we could use the quadratic formula and use a scientific calculator. Clearly, I'm not going to ask you to do this by yourself. But if I asked you to do it algebraically, that would mean I want you to show me using the quadratic formula. So here's A and here's B. You plug them in, put them in your calculator as we've discussed, and find your solution for your x-intercepts. For this next one, you could find the vertex, and remember you have a formula for the vertex where x is equal to negative b over 2a. So you could plug in your numbers and calculate that algebraically if you needed to. The second type of question that we did in this one and the last one was mystery numbers, where you're being asked to find the number that's described. Find two consecutive odd whole numbers such that the sum of their squares is 130. Now here comes the first type of question where you have to tell us what variable you're going to use. So I chose to say let x and x plus 2 be the numbers, keeping in mind that if x is the first one, the next odd number to it will be 2 away from it. And then I translate what they tell me in the question where the sum of the squares, and so x squared and x plus 2 squared is 130. Now I'm going to go ahead and actually figure this out by hand. So I go ahead and multiply this out. X plus 2 times x plus 2. X squared plus 4x plus 4. Gives me a final quadratic of this one, and I recognize, okay, I need to factor out a 2. And then I can see, all right, I'm looking at a 9 and a 7. So positive 9 and 7 will do it for me, negative 7. I actually did this out the long way, but because this was a 1, you could actually go directly to your answer. Gives you two possible answers. X is a negative 9 or a 7. Now, if you remember the text of the question, it said that these were whole numbers. So the only one that makes sense right now is the 7. And if X is a 7, then 7 plus 2 is my second one, so 7 and 9. Now, if I had changed the text of this question and said that these numbers were integers, then you would have had to keep the negative 9 as well, and then you would have had negative 9 and negative 9 plus 2, which is negative 9 and negative 7. So you would have had two possible solutions. Okay, so those are some of the strategies so far, and these are the questions that I've asked you to do for your homework. So good luck with everything, everyone.